Okay, we're back, and this is uh, P-Dog Does Science with this Chapter 16 Solutions lecture. So we'll start with the nature of solutions. Uh, Solutions in general are mixtures. All solutions are mixtures of two different substances. Okay, mixtures. Okay, there's a number of different types. There are two different types. There are heterogeneous mixtures, which have visibly different parts, and we refer to this, or this is my term, they are telem-apartable. That means you can tell the two different kinds of things that are mixed into the solution. You can tell them apart visually. So, for example, if you take a clump of dirt and you mix it up with water and shake it up really well, you can still see the particles of dirt and little shiny pieces and stuff like that, aside from the water that it's all mixed in. Okay, then there's the other kind, which is the homogeneous. In a homogeneous solution, the parts can't be distinguished from each other. And a homogeneous mix is also called a solution. So you can make, for example, milk. Milk is a homogeneous solution. In fact, if you have homogenized milk, what they've done is made it even more homogeneous by sticking it in a blender and mixing everything up. Okay, so the definition of our solution is this. It is a homogeneous mixture of two or more substances in a single physical state. For example, Kool-Aid or air, or soda pop or sterling silver, where the air and sterling silver are actually a gas and a silver portion, gas and a solid portion of versions of the solution. Right? And Kool-Aid and soda pop, and you guys have seen those, they're the regular solutions. However, soda pop is only a homogeneous mixture if it is not fizzing at the particular time. So if you see it in a bottle and it contains bottle, then it's a homogeneous solution. But as soon as you open the bottle and you see the fizz come out, you can see the bubbles, therefore it would be a heterogeneous solution. Right, so we see that solutions can actually take any kind of state as long as they're all in the same physical state. Kool-Aid's liquid, soda pop's liquid, air and sterling silver are a gas and a solid. So it does kind of raise the question, what about ice water? We'll come back to that one maybe later. Okay, so, then how the properties of solutions. Solutions are when particles are very small, and they exist as atoms or molecules or even ions, where all the particles could pass through a filter paper. This would be coffee. Why coffee is a solution? Because all of the particles in your coffee can pass through the filter. Okay, the particles are evenly distributed or mixed throughout at a molecular level. The molecules. Then we have particles that will not separate no matter how long the solution sits. So you can have coffee and it will stay black for as long as you have the coffee sitting there on your counter. It can be days and days, kind of like what happens in my house when somebody is drinking their coffee and nobody wants to clean it up. The sugar, for example, in a sealed container of Kool-Aid will never settle on the bottom. It will stay dissolved and it will stay sweet forever. Just like Gatorade does the same thing. Okay, now, we have two different parts to a solution. We have the solute, which is the substance dissolved in a solution, and a solvent, which is a substance that does the dissolving. There can be only one solvent in a solution, and it is generally the most abundant substance in the solution. Soda pop, for example, is sugar, flavoring, and CO2 are all the solutes, where water is the solvent, the most abundant substance. Okay, with alcohol and water are completely mixable. They dissolve completely with each other. And so it'd be whichever one is the most abundant is the solvent.